most of what we did on this lesson was just look at some applications of some special sequences. Series did some fun activities and such. But there was one new thing as far as content-wise that you needed to learn, and that was called summation notation. Let's look at that. All right, a lot of this lesson we were doing some different activities that involved sequences, but there was one piece of this day that we did take some notes, and that was on what we called summation notation. Summation notation, I think we brought up the other day, is this big sigma. That stands for the sum of something. And what we do is we create some sort of a rule out here, and then we designate our variable to start someplace, so it's going to start at 1, and we're going to plug 1 in for the variable and see what we get. And then what you do is you increment this value up 1, so it goes up to 2 now. And so then you put 2 in and you see what you get, and then you put 3 in and you see what you get, and you keep going until you get to this number up here. And since we're got this big summation sign, that means take all those different values and add them up. So let's try this one. I'm going to start off and I'm going to let k equal 1. So if I plug 1 in here, I'm going to have a 1 plus 1 squared. Well, that's just 2. So I'm going to have a 2. Plus, and now we increment and we go up another 1. So now it's going to be a 2. So I put, actually I didn't want to do that. Let's do this. It's going to get messy. So let's make this now be a 2. So plug 2 in. So that's 2 plus 2 squared. So 2 plus 4 is 6. So the next number is going to be a 6. And I keep going, and I keep incrementing. So now it's a 3. So 3 plus 3 squared is 12. And now I'm going to make it a 4. And 4 plus 4 squared is 20. And now I'm done because I hit this number that's up here. And so now you just add these up. So I got 8, 20, looks like I got 40 for a sum. Okay, let's try another one. Let's do number 2 here together. Now this one has a lot of terms. It goes from 0 all the way up to 5. So I'm going to have to, I don't know, this may get a little bit messy. Let me do this. Okay, so the first thing I'm going to do is I'm going to plug 0 in for Q. So then when I plug 0 in here, I'm going to have 0 minus 3. So that's going to end up getting me a negative 3. Now you have to increment, so now make Q equal 1. So put 1 in here. So that's going to be an 8 minus 3. So my next number is a 5. Now make it be a 2. So that's 16 minus 3. So that's 13. Now make it be a 3, so that's 24 minus 3, so 21. Now make it a 4, so that's going to be 32 minus 3. And then the last one, let it be a 5, and so that'd be 40 minus 3 is plus 37. And then we just take all of these numbers and we add them up. And those end up equaling 102. So that's the sum of all of those values in that sequence. Okay, let's try one more. You do this one, pause the video, see if you can figure this one out, and then come back. Okay, take a look at what I got, see if you agree. If not, look and see where you might differ and get it figured out. I'm going to go ahead and move on. Okay, so let's try going the other direction. So let's say I already have this series. And notice now that there's not commas between these, but there's plus signs. So when there's plus signs, then we're talking about summation, not just some sort of arithmetic or geometric sequence. So if it's arithmetic or geometric, we can just write our explicit rule and use that in our summation. But we might want to simplify it if we can. And so let's look at this first one. All right, so you got a 3, 6, 9. Looks like we're going up by 3s. So that makes that arithmetic. So in summation notation, we'd start off, and you can use any letter, doesn't matter, and you can start different places. I usually start with 1, and then maybe I'll have to tweak that. That one we did earlier started at 0, but I'm going to start at 1. And now over here to the right, I just write the arithmetic rule. So the arithmetic rule says that you're going to start at 3, you're going to add 3 n minus 1 times. So that's the explicit rule for an arithmetic sequence. And how far do I go? Well, I have 1, 2, 3, 4, 5, 6 different values, so I'm going to end at 6. The one thing that you might want to do is try to simplify, especially something like this, where we could certainly distribute that and clean this up. So that's really going to become 3 plus 3n minus 1, or I'm sorry, minus 3. And so actually the 3's cancel, and that all simplifies to just 3n. So your final answer should look like this. And so it's probably a good idea to maybe check if you plug 1 in, you get 3. Plug 2 in, you get 6. 3 in, you get 9. So that makes sense there. So there's your final answer. Let's try number 2 here. This one is not arithmetic. It appears to be multiplied by 2, so that's a geometric sequence. So I'm going to start off, let n equal 1. I know that I'm looking to get 4 terms, so I'll stop it at 4. We write a geometric rule, so your first term is 8. You are multiplying by 2 n minus 1 times, so that's your geometric rule. And looking at that, I don't think there's any simplifying I can really do. Because the 8 cannot actually get multiplied by the 2, order of operations says you have to do this exponent before you would do this multiplication. We can't multiply these and make it a 16. I think we're done. That's your final answer. Now, not everything is an arithmetic or a geometric sequence. Sometimes there's just some sort of a pattern going on. So let's look at a couple of those. If you look at number 1 here, and look at what pattern we have going on, and then we just come over here and write our summation. And I usually start with n equals 1, but I can change that. And looking at all of those terms, it would appear that it always has a 2 times something squared. This something is just going up by 1. Well, that's what this does. It just goes up by 1. And so the first value I want it to be is a 1, so how about if I just put an n right there? Would that work? Test it. Put in a 1. That matches. If you put an increment and go up to a 2, you plug in a 2, then it looks like this term. You plug in a 3, it looks like this term. I think we've got it. We need 4 terms, so put a 4 up top. There's your summation notation. And this doesn't necessarily have to be any specific rule. We just saw the pattern going on. All right, let's try one more. Let's do number 2 here. Again, not necessarily arithmetic or geometric, just an obvious pattern of sorts going on. So I'm going to start off my summation. Let n equal 1. All right, maybe I'll start with the denominator. I need it to be a 4, and then a 5, and then a 6, and then a 7. So if that's incrementing by 1, all I got to do is put my n and decide what to make that first number work out for me. So an n plus 1 would get me a 4. And then as this n value increases, the next time I'd put in a 2 plus 1. Oh, I didn't write that right, sorry. That is not what I want. I'd want that to be an n plus 3. That's how I'm going to turn that into a 4. So then when I make this a 2, it'd become a 5. When I make this a 3, it'd become a 6. So I think I've got it there. On the top, to turn this 1 into a 3, and notice what happens with it. It's a 3, and then it's a 4, and then it's a 5, and then it's a 6. So that's also incrementing by 1. So I just got to figure out how to make the first one be a 3. That's going to be n plus 2 more, and then that'll equal a 3. And as this increments, so then when it's a 2, I'd have a 4. And then when this becomes a 3, I get a 5. So I think that's matching up. Now let's work on this number. It's a 7, 8, 9, 10. Again, just incrementing by 1, so let's work on getting the first one to come out. So n's going to start at 1, so I'm going to want to add 6 to it so that it turns into a 7. And then you can check it. If it's a 2, it'll be an 8. If it's a 3, it'll be a 9. So I think we have it there. Now that's a little bit messy. There is probably an easier way to write this. So you'll find that not all of you maybe have the same summation notation, and it still maybe works out okay. So let me try one that might look a little bit simpler. I'll still do my big sum. Oh, I'm sorry. And on this last one, don't forget your number up top. I ended up with 5 terms, so that would need to have a 5 up there. All right, so looking at this right here, I'm always having to add something to my n. Well, what if I just started out higher right here? When I look at these 3 numbers, the smallest number is a 3. So what if I just started off right here and made n equal 3 just right off the bat? Then up in the numerator, I would just need that to be an n, because that's what I want it to be, is a 3. And the 7 would be an n plus 4. Over, to make the denominator be a 4, I'd have an n plus 1. Now let's check it on the next term and see if it works. So if we increment that to a 4, then I'd have a 4, this would be an 8, and this would be a 5. That's what I want. And if I made it be a 5, I'd have a 5, 9, 6. That's what I want. So I think I'm good. And just to figure out how many terms are there, 1, 2, 3, 4, 5. So I'm going to want to make sure that I have 5 terms when it's all said and done. Check your last term. You want your denominator to be an 8. So what would I need to plug in for n right here to make that be an 8? Well, it'd have to be a 7. So it ends at 7. 3, 4, 5, 6, 7 would be 5 terms. All right, so either of those is fine. You just choose what makes sense in your head and go with it. All right, so you have some worksheets here for tonight for homework. Good luck.